Hello from New Zealand. I'm Dr. Lee Morris from Equibreed Art. Today I will present the results of our study which demonstrated that good embryo recovery rates are possible after storing thawed stallion semen for up to 24 hours at 17 degrees in a protein-free extender. The aim of this study was to develop a simplified protocol for vets to use for frozen semen insemination and to optimize fertility and to reduce shipping costs. Most AI protocols currently used in practice involve intensive management of either multiple inseminations or multiple scans to optimize timing with ovulation and to compensate for the relatively poor fertility of stallions when compared to other species. Despite this hard work and relatively high insemination doses, the per-cycle conception rates range from 40 to 60%, and a total of 800 million total sperm are inseminated within 12 hours of ovulation. In practice, frozen semen logistics can be very complicated and expensive, involving couriers, liquid nitrogen tanks, and dangerous goods paperwork. For this experiment, we used frozen semen from 3 stallions and 42 insemination cycles. We thawed the semen and stored it at 17 degrees for 6, 16, or 24 hours before performing fixed time insemination at 40 to 41 hours after desirelin treatment. So all inseminations were performed between 9 and 10 a.m., which is within 6 hours of anticipated ovulation. For each insemination, we thawed 3 straws of frozen semen and processed it through a microfluidic device which selects a small population of viable sperm. This video shows how the sperm are selected as they swim out of the thawed semen extender through the carefully designed pores in the membrane of the microfluidic device and into the top layer of the sperm-safe protein-free extender. After recovering the sperm from the top chamber, it is stored in the protein-free extender at 17 degrees until fixed time deep uterine insemination. The sperm motility and concentration was evaluated by computer-assisted semen analysis at each time point. The fixed time insemination protocol was designed so that mares were inseminated at 40 to 41 hours after ovulation induction with the GnRH agonist desirelin. At 5 p.m. when each mare was in estrus with a 35 mm follicle, uterine edema, and a soft cervix, we treated her with desirelin. The next day we scanned her to make sure that the follicle was developing normally, and then we thawed the semen at the time required for each treatment group. On day 2, insemination was performed between 9 and 10 a.m. with 1 ml of stored semen by deep uterine insemination method. On day 3, we scanned the mare to check for ovulation and fluid, and each mare was scanned a total of 4 times during the protocol. We observed that the sperm longevity was very good for up to 24 hours after thawing under these conditions, and that total and progressive motility was maintained above 55% during this time. Overall, for the 3 post-thaw storage times, there was a 52% embryo recovery rate. The semen stored for 6 and 16 hours produced embryo recovery rates of 54 and 69%, and the recovery rate of embryos from the 24-hour group was 31%. These embryo recovery rates are consistent with those reported from intensive insemination programs using frozen semen. Of all of the insemination cycles, only 1 mare had detectable endometritis based on ultrasound scans. In summary, we are very excited to present the results of this simple insemination protocol. It means we can thaw the semen the afternoon before insemination and ship it to vets, and they will not need a liquid nitrogen tank to store the semen in or to ship tanks around. We can also send this semen overnight in an eco-friendly box Implementation of this protocol will reduce the number of ultrasound scans required, and satisfactory embryo recovery rates can still be achieved. I would like to thank the New Zealand Equine Research Foundation for funding this study, and if you have any questions, please feel free to contact me and these contact details below. Thank you for your attention.